refrigeration cycle is pretty cool. We use it to cool our homes, keep food fresh, and in all sorts of other applications. But have you ever thought about how it all works? Think about it. A refrigeration system has to fight against entropy. The second law of thermodynamics says that heat has a natural tendency to move towards areas with less heat. If you left a cold glass of water on a counter for a couple hours, it would eventually come to room temperature. The heat from the room moves into the water, but a cold cup of water in the fridge stays cold. To put it broadly, a refrigerator moves heat energy from a cold place to a hot place. It exploits the enthalpy, sometimes called latent heat, of the gas to liquid phase change. Imagine getting a drop of rubbing alcohol on your arm. The place where the liquid falls feels cool as it evaporates. This is because the gases have more energy than liquids at the same temperature. As the liquid evaporates, it draws energy from its surroundings to change into a gas. The energy for this process is called the heat of vaporization. Similarly, when the gas condenses, it releases heat into its surroundings. In a refrigerant is repeatedly condensed and vaporized as a way of moving energy. A pump, called a compressor, compresses gaseous refrigerant into the liquid phase. As the liquid travels through the condenser, heat is expelled into the surroundings. This relatively cool liquid then moves to an expansion valve, which kicks the liquid back into the gas phase through the evaporator. The gas passes through the evaporator and absorbs heat through its surroundings. This gas then comes back to the compressor and starts the cycle all over again. As the refrigerator runs, it creates a hot side at the condenser and a cold side at the evaporator. We can then use this to move heat for all sorts of applications, like this fridge. The cold side is inside the fridge, and the hot side's in the back. And if you were to stick your hand back there, you'd see that it feels a bit warm. But wait, there's problems. The refrigerants that we use in these kinds of systems have to be things that are easy to get from a liquid to a gas and vice versa. Most of them are gases at atmospheric pressure and temperature. Many are potent greenhouse gases when they get into the atmosphere. Now, normally they shouldn't go in the atmosphere, but leaks and improper disposal are always risks. Additionally, some newer refrigerants might have health risks that we haven't fully assessed yet. It sure would be nice if we could move energy using a medium that doesn't evaporate when you look at it funny. Okay, so in 2019, two different research groups both reported that neopentyl glycol, this molecule, could serve as a solid refrigeration material. One of the studies even reported that it had a phase transition enthalpy similar to that of the commercial refrigerant R134A. Now you might be thinking, how does a solid material act as a refrigerant? Do you melt it? Do you vaporize it? Can you ever truly understand it? Can you ever truly understand anyone? Now that's a solid question. Neopentyl glycol, or NPG, is a material known as a plastic crystal. Plastic crystals are materials made up of small, spherical molecules that can rotate and deform while still keeping their centers of mass arranged in a crystalline structure. This is called the phase, or particular arrangement of molecules in a solid. Solids can have multiple phases. For example, if you took regular NPG, which is a plastic crystal, and you squeezed it really hard, its molecules would reorder themselves into a rigid crystal structure, and they can no longer deform. This is called the ordered crystal phase. Just like a phase transition from gas to liquid, this process can give off energy. And going in the reverse direction can also cause energy to be absorbed. Using a solid material in place of traditional refrigerants could help reduce the environmental impact of refrigeration. If an NPG-based system leaks, nothing goes into the atmosphere, it's still a solid. Plus, it's cheap and a readily available material with minimal safety concerns. In the Pencer lab at Texas A&M, we're working on synthesizing chemicals that are very similar to NPG to see if they might have better thermal properties and to investigate what factors influence those properties. I hope that this video has helped you learn a bit more about the vital technology that is refrigeration and about some of the advances that may improve its environmental friendliness. Thanks for watching.
I'll cut this out.